Okay, so today we're going to start talking about applications of quadratic functions, more specifically like how to maximize and minimize them. We did it graphically already. Remember where we had like the parabola and we found the maximum. So now we're just going to do it algebraically now that we have more information about how to find the vertex using an equation for the function. So a couple things to remember. So every quadratic has either a maximum at the vertex or it has a minimum at the vertex. Which means that when we're given a problem where they ask us to find the maximum or the minimum, so find maximum or minimum, that's just another way of saying find the vertex. They could also say maximize minimize. Just the wording varies, but all of it really just means you're finding the vertex of a particular function. So what's going to be really important as we do these problems is labeling. I know I tell you guys that all the time, but for real, because like we have in the past, we've done application problems where we write an equation with one variable in it and then we solve and we go x is whatever and like done. What we're going to be doing here is writing a model, so a quadratic model, which means we write a function, and then there's all sorts of things we can do with the function, right? And so like we might find one x value in part A and a different x value in part B, and it's really important that we keep track of what it is exactly we're finding every time we solve an equation or use a formula, because that's going to help us not get all mixed up about what all the different numbers mean. So, and sometimes we have even more than one function in a problem. So by labeling really carefully, we can always distinguish between what it is we need to use to find what we're looking for. So let's start with this guy. We've done this one before. We did it graphically on some homework assignment. We're going to do the same thing now, except instead of using the graph to maximize, we're going to do it algebraically. So we will start with a picture. Right, so we have our beach and our 3 swimming lanes. And the beach is supposed to touch one side of each lane. So there's my beach. Just like every other application problem we've done, we always want to start with identifying what our x value represents. So what do you want x to represent?
Width.
Sure, so we'll call x the width. And even though I labeled it on my graph, I'm also going to write width next to it so that there's no confusion later on. And then if that length of rope is x, then these 3 lengths also have to be x feet long. So then there's just one side left that's not labeled. How do I find that length?
$240 minus 4x.
Good. So we started with 240 feet of rope. And to make the 4 lengths that we labeled already, we had to use 4x feet of rope. So that's how 240 minus 4x is how much we have left of the 240 to make that last length. So now I'm going to go, now that I've set it up, I'm going to go back and see what it is I'm trying to figure out. So we have a beach forming one side. We want to find the maximum total area. So when I see maximum, that tells me what?
Parabola.
So, well, when we see maximum, it tells me to find the vertex, right? If I'm maximizing something, that means find the vertex. Well, then I have to figure out what it is I'm finding the vertex of, right? So I look at what I'm maximizing, and I see it's the area. So I need an area function. Because it's hard to write a model if we don't know what the model represents, right? There's all sorts of things we could do with a rectangle. We could do perimeter. We could do just one of the sections. There's all sorts of things. So it's important to see what it is you're maximizing, because that tells you what kind of function you have to write. So I need an area function. I want its input to be x. And area is just length times width, right? So we have x times 240 minus 4x. And the last time we did this, we didn't multiply it out because we weren't really doing anything with the function itself. We just skipped to the graph, right? But now that we're actually going to be using the function to find the vertex, we'll go ahead and distribute to put it in general form. So, and I'll put it in descending order as well. So a of x equals negative 4x squared plus 240x. Okay, so now I have a function. What do I want to find? I want to find the vertex, right? How should I do that? So if I set the equation equal to 0, that would tell me where the area was 0, right? Which isn't going to be its maximum area, right? If we think about the graph, if I set it equal to 0, I would find those 2 points, right? Which theoretically I could do. I could find those 2 points and then average them to find the vertex, and that would work. But there's a quicker way as well, right, that we learned about on Friday.
Complete the square.
We could complete the square. We did that last week to put it in standard form, right? But there's an even quicker way than that.
Plug in coordinates for the x, right? That's the one.
Yeah, well, not the quadratic formula, but it's in red. The vertex formula, right? Remember, we said the quadratic formula gives us the x-intercepts, and if we average those, we get the vertex formula. So all of your ideas are valid. Like, we could have completed the square and put it in standard form. We could have found the intercepts and averaged them. Like, there's all sorts of things we can do to find the vertex. This happens to be the quickest way to do it, but that doesn't mean that it's wrong to do it another way. But I think you'll find this. We're not like trying to find anything else, right? Like, it might be efficient to put it in standard form if we wanted to get a lot of different things from it, like the intercepts and the vertex and whether it opens up or down, all these things. But for our purposes here, we're just trying to find that one point. And so we don't necessarily need to put it in standard form just to find the one point. So instead, we will use our vertex formula, which is x equals negative b over 2a. My b is 240, and my a is negative 4. So I have negative 240 divided by negative 8, which is 30. one thing to be careful of, since you'll be using this calculation quite a bit over the next week or so. So I got 30. What did I just find?
Your X value.
So I found the x value of the vertex. Good. So in terms of the problem, what does that represent? So 30 is the maximum total area?
No, 30 is the length of the width.
Very good. So it's the width that will produce the maximum area. And I was really careful when I did this to write x equals at the beginning so that once I get a number, I can remind myself that's an x value, right? And I can go back and be like, oh, what was x? It was the width. And then at this point, I always go back and read the question again and like figure out what it is I'm actually trying to find. So what they're actually asking for. So what are they asking for here? Yeah, the maximum area. How would I find that? To what? The area function. Very good. So I found the x value that'll maximize my area. In order to find the maximum area, I'm going to use my area function with that x value. So I want a of 30, which equals -4 times 30 squared plus 240 times 30. So a of 30 equals, if you don't already have your calculator out, you may want to get it out. There's a lot of calculations today that you might not want me to do in my head if you want them to be accurate. Or if you want to be here less than 2 hours. So what's our maximum area? 3,600. Do you guys remember when we did this on the homework, right? That point was 3,600, which is exactly what we just found, right? So the maximum area is 3,600 square feet. Any questions on this one?
Where did we get the negative b over 2a again?
That is the vertex formula. So we derived that on Friday by averaging the two solutions to like just a standard quadratic equation. It'll be on the test. That's one that I'll give you on the test in the box on the front. So once you know that you need to find the vertex, go back and be like, oh look, vertex formula. It'll be labeled and everything. The only one that I'm not giving you on the test is the quadratic formula, because certain powers that be really want you to memorize it. Memorize away.
What's the Pop Goes the Weasel song?
I am not singing to you, but you can look at Riley will.
Riley
know
knows it. Okay.
That's what you want to
Put it on a post-it, put it on your mirror or on your dashboard. What a waste of a class. Just singing Pop Goes the Weasel. All that does is get Pop Goes the Weasel in my head. Okay. We have seen problems like this before. These were the ones where like we made a table, right? And then we found 2 points, used that to write a linear equation. We're going to set this up a little bit differently in this setting just because doing so will allow us to avoid that whole step where we have to write that linear equation using 2 points. And the slight change we're going to make is that instead of x representing the price or the quantity, I'm just going to have X represent the change in the price or the change in the quantity. In this case, it's the change in the price. So let X represent the price reduction. And if that wasn't given to you, if you had to come up with that on your own, because really these problems, like for our example, I've kind of laid out all the steps for you. Like when you're given this on homework or a test, you'll be given the first paragraph and you'll be given the question at the end, right? This is just to show you the steps you want to go through regardless of if I set it up for you. So if I don't tell you what X represents, these problems, you always want it to either represent the change in price or the change in quantity. And the way you decide which one it is going to be whatever is changing by 1. So in this case, when we change the price by $1, so lower the price by $1, we get 20 more pairs of hiking boots. If I said that raising the price by $10 will result in 30 less pairs of hiking, or 1 less pair of hiking boots, then I would make X the change in quantity, because that would be the thing that's changing by 1. So we have X representing the price reduction. So the first thing we want to do is represent the price and the quantity as an expression. We know that the price of $97 corresponds to a quantity of $6.50. However, I want to change the price. I want to lower it, right? So what operation should I do to lower the price?
Subtraction.
So 97 minus, and how much am I lowering the price by? So every time I lower the price by $1, this information tells me how many more pairs of hiking boots, right? But it doesn't mean I'm always like if we just lowered it by $1, we could be like, okay, the price is 96, I'm done, right? What is X?
The price reduction.
So how much am I lowering the price by? X, yep. Because I'm not really sure if I want to maximize my revenue. I don't know if I want to lower it by $1, by $20. Maybe I want to raise it by $50. Who knows? So if I am lowering the price, what happens to the quantity? The price goes down. Quantity goes up. They always go in opposite directions. So if one is subtraction, the other one has to be addition, because people are willing to buy more at lower prices, right? So they always change in opposite directions. And how much am I raising the quantity? Or how much does the quantity go up by? 20 for every $1. How many dollars am I changing the price by? X. So it's going to go up by 20x. Right? If X was 2, it would go up by 40 pairs. If I lowered the price by $5, it would go up by 100 pairs. So now I have an expression for my price and for my quantity. When you're doing this without the setup given to you, make sure you clearly label those. So just like we did here, price equals, quantity equals. I mean, if you don't want to use as many words as I use, that's cool. But make sure they're clearly labeled so you can come back to them later on. So now I want a monthly revenue function. How do we find revenue? Like in general, how do you get revenue? Yeah, price times quantity, right? So price times the number sold. And so I'm like, oh, how am I going to write that function? Well, I look for price. There it is. And then I look for quantity, which is the same as the number of. It can be tempting when you see price to be like, oh, the price is 97, which is true, like for one specific combination, right? Like we could put 97 and 650 in there, but then that's not a function of x. That's just a specific value. If we're writing a function with an input of x, then we definitely need variables on the other side rather than just numbers. So I'm going to go ahead again and simplify that so that we can work with it. So r of x equals, oh, I could do this by memory, but I think is it 6150, 63? It's something 50, 60.
63.
Thank you. And then plus 1,940 x minus 650 x minus 20 x squared. And then we'll combine like terms and put it in descending order. So I have negative 20 x squared plus 1,290 x plus 63,050. I may want to double check my numbers and make sure I'm not just lying. There you guys got? You're just going to trust me? Okay, good. So now we finally get to what we're looking for. Determine the price reduction that results in a maximum monthly revenue. So again, I'm going to go through this bit by bit and identify what it is I'm trying to find and then what I have to use in order to find it. So I am trying to determine a price reduction, which means I want to find an x value because the price reduction is represented by x. And then I want to maximize something, which means I want to find a vertex. The thing I'm maximizing is revenue, which means I want to use the revenue function. This process of going through and identifying what it is you're trying to find and what function you're using to find it is really important in these problems. Especially like tomorrow we'll be talking more about financial applications, and you'll have in the same problem, you'll have a cost function, a price function, a revenue function, a profit function. And so that whole thing at the end where I was like use r of x, like it might seem kind of obvious in this one because it's the only function we wrote. Right? But if we had like 4 functions, it's important to like deliberately be like, what is it I'm actually trying to maximize here? So that you're using the right function for each given problem, because it'll change from problem to problem. So these problems, more than anything we've done so far probably, it's probably not going to be successful to like try to memorize like, oh, this is the one where I write that one thing, right? Type deal, like memorize like a process. It's more that you want to go through every single one and like identify like this is what I'm looking for, this is what I'm going to use to find it, because there's just so many different things we can be looking for that it's going to get really confusing if you just try to memorize formulas and plugging things in. So if I want to find x, I'm saying find the x value of the vertex of the revenue function. So I'm going to use my vertex formula. And then I'm getting that b and a from my revenue function. So negative 1290 divided by 2 times negative 20. And that ends up being 3225. I think. 3125? No, I think it's 32. Okay. What did I just find?
Value on the vertex.
Well, I found the x value, right?
There we go.
The
the price reduction, which will give the maximum. Yep, good. So 32.25 is the price reduction that maximizes revenue. What that means is that any other question I have to answer that involves maximizing revenue has to use that X value. So like that is now set in stone. If I'm maximizing revenue, that occurs where X is equal to 32.25. So now every time I read a question that's like, what will this be if you're maximizing revenue? I immediately go back to X equals 32.25. So what's the next thing I want to find? The price. So how am I going to find the price? Is it $32.25? Yeah, so I set this up really nicely for myself because now I can just go back and find the word price and be like, oh yeah, the price is 97 minus whatever my X value is. So we have 97 minus 32.25, and that gives us 64.75. How many pairs of boots should I sell? How would I find that? Yeah. Mm-hmm. Yeah, so right back up here, right, it tells us exactly how to find a quantity that corresponds to a certain price reduction. So 650 plus 20 times 32.25 is like 1,000, what is it? 19, I think it's 19 something, maybe it's 14 something. Oh, I'm totally off. 12.95 pairs. And then what about the revenue? How am I going to find that? So we're going to use our revenue function, right? So R of what? 32.25. Good. So that's negative 20 times 32.25 squared plus 1290 times 32.25 plus $63,050, which gives me what?
$104,007.50.
That feels a little bit big. Did you remember the negative on your 20?
Yes. I got 82,000.
Does anybody agree with either of those?
I got 83,000 as well.
Yeah. So you said 83,000. 851.25. Good.
Yeah.
So our maximum revenue is 83,851.25. Questions?
Why would you not just multiply what you had, like on the side that you said $64, that stuff, can you just do that?
Absolutely. Yeah, so to find revenue, you could also, since you found the price and the quantity that maximizes revenue, you could definitely just multiply those to get your revenue. Sometimes maybe we won't find both of those, and then you want to use the function. Probably if I was taking a test and I was doing this, I would do both of them and make sure they matched, because if you didn't get the same thing both times, that would be a good clue that there's a mistake somewhere. Other questions? Okay. Let's talk about throwing stones. So, again, just want to label. They give you here the initial height and the initial velocity that the stone is thrown with, but you guys won't ever have to actually write the height function. Those numbers play into the height function. You can kind of see where the 60 and the 30 come into play, but you won't be asked to actually write it. They'll give it to you every time. So in this case, t is equal to the time, and h of t represents the height t seconds after being thrown. And I just like to write those out because, well, first of all, it forces me to think about what everything actually represents. And then secondly, it gives me an easy thing to go back to without having to read through the problem again when I'm looking for stuff. So again, we're going to just go through the question piece by piece, figure out what we want, what to use to find it. So we want to find a height. So we need to find some height. And we're given a time, so t equals 2. So what should I do?
Just plug in 2 for t.
Yeah, we're just plugging. If we want to find a height and we know the time, then we're just finding h of 2, which is negative 16 times 2 squared plus 60 times 2 plus 30. So h of 2 is what?
86.
86. What did I just find?
The height this one is gained.
So, well, I want the height that's gained, right? Does that mean that I found it? I mean, it'd be really nice if every time we did a calculation we found exactly what we wanted, right? But yeah, so the h of 2 is the height of the stone 2 seconds after being thrown, right? So this is the height.
So you have to subtract 30.
Mm-hmm. After 2 seconds. So it's the height off the ground after 2 seconds. But we started at a height of 30 feet off the ground. So we gained 56 feet, right? So we gained 56 feet. Because this is the ground. We started up here. This is 30. At some point up here, we're at 86. So this is the amount of height we gained, right? Whereas when we plug it into h, we're finding this height off the ground. Okay, so now we want to determine the time at which the stone reaches its maximum height. So I see determine the time, and that tells me to do what? Yep, find t. And then I read maximum, which tells me
Vertex.
find the vertex. Good. And the thing I'm trying to maximize is height, so I should use the height function.
Yeah.
Yep. Again, in this setting, that might seem a little silly that we bother writing that, but when we have more than one function, it's not quite as simple to just take whatever you have, right? So we're finding the vertex of the height function. We want the t value, so we're going to do t equals negative b over 2a. Our formula says x equals, but what they really mean by x equals is the input, right? And so in this case, our input is t. So we've got negative 60 over 2 times negative 16, which is
1.875.
So the stone reaches its maximum height after 1.875 seconds. Next, I want to find the maximum height of the stone. So, what is the height? I want to find h. I see maximum. And now I know that anytime I'm doing anything regarding the maximum height, I know what? It's the vertex, and it occurs at 1.875, right? So any question I read at this point that talks about maximizing height, I'm like immediately t is equal to 1.875. So I have a t value. I want to know the height after that much time, so I'm going to use my height function and evaluate it for 1.875. So negative 16 times 1.875 squared plus 60 times 1.875 plus 30. And we get what? 86.25. So the maximum height is 86.25 feet. Okay, last question. I read this sentence and I see the words how long, which tells me what? I'm looking for time, so find t. And then I see hits the ground, which tells me what?
Your height is at 0.
Yeah, that height is 0. So I want to find the time that corresponds to a height of 0, which means I'll take my function and just replace h of t with 0. So we're setting our height function equal to 0. And this is a place where the quadratic formula comes in handy. I don't need an exact answer, so I'm okay with just putting it in my calculator and getting a decimal, because it wouldn't make sense to be like negative 60 plus the square root of 13 over 80 seconds, right? That would be a silly way to answer the question. So it makes more sense to have a rounded decimal. It's in general form, it's set to 0, so we can use the quadratic formula with a equals negative 16, b equals 60, c equals 30. If you have the quadratic formula program in your calculator, you're more than welcome to use it once you've gone this far.
Where do you find that?
You get it from me, or you can Google online how to program your calculator.
No, I have it in here, but I forgot.
Oh, it's under program. And so what do we get for our t values? PRGM.
4.196.
Uh-huh.
Blah, blah, blah.
So like 4.2-ish, and remember there's two solutions.
-0.4.
Very good.
Yo, this feels like cheating.
She.
I mean, it's not, because the important thing here is that you recognize that when you can use it, right? Like, you can only use it if you're solving a quadratic equation that is in general form on one side and is set to 0 on the other side. And so I would want to see you get it to that form, and then knowing that you can only use it when a decimal approximation is okay as well. So if we wanted an exact answer, we couldn't just plug it in our calculator. But other than that, it's not cheating. I care more about the interpretation than the number that you spit out, right?
I got
So,
an error message. I've done it before, but I forgot how to do it, so.
so you you execute the quad formula or program, then hit enter,
Okay.
and then it should say A
Oh, yeah.
equals, and then you
just
enter
enter the
your
coefficients.
yep A, B, and C, and so we can't go back in time, right? So it doesn't make sense to have a negative answer here. So it hits the ground. After 4.2 seconds.
Who threw that rock like 86 feet or
Yeah, maybe they like shot it out of a cannon, or maybe it was He-Man.
Can you do that real quick without using a calculator? The last step.
So without using the program?
Yeah.
Yeah, I do. It's expensive. It takes forever also. It takes like half a second. So then this last question really is just kind of review from the beginning of the semester. So we talked at the beginning of the semester about net change, right? So net change, we're just doing it with a quadratic function instead of a linear one. And then just interpreting inputs and outputs. Right, so looking back at your notes from the beginning of the semester, or if you don't have your notes or can't find it in your notes, there was a really similar question on the first test. So that's a good refresher for how to do these interpreting problems. And we can talk about it tomorrow too if you're not able to find what you need to do this. But definitely look, because it's good to refresh your memory.